Hi, hello, and welcome to homework video number 18. This is one of our review ones. So first we're going to look at inverse and composite functions, and then we're going to do a little bit of review on quadratic functions. I'm going to try to do most of these without a calculator because these are the types of questions that could show up on a non-calculator section of your test. Okay, so let's look at this one first. This one says let f of x equals square root of x plus 2 for x is greater than or equal to 2 and g of x equal 3x minus 7 for this just means all real numbers. Okay, so we have two separate functions labeled g and f, and then we've got about 3 questions below. The first one says write down f of 14. So write down f of 14. What this really means is when x is equal to 14. Okay, when x is equal to 14, what is my value of y? I see that it's for the f function. So for this function, everywhere I see x, I'm going to plug in 14. Okay, I know I didn't give you a ton of space here. I have an extra sheet of paper. If you need to show work on a separate sheet of paper, you are welcome to do that. So I write down f of 14. Well, if I've got f of x, can we see this? Yes. If I've got f of x is equal to square root of x plus 2, f of 14 is equal to wherever I see x, I'm going to plug in 14. So I've got 14 plus 2. Okay, 14 plus 2 is 16. Square root of 16 is equal to 4. So my answer here is 4. Okay. Next says find find g of f of 14. Now this is my composite function or function within a function. Okay, so I'm going to write my two functions in different colors here. I have f of x is equal to square root of x plus 2. And I have g of x is equal to 3x minus 7. Okay, my question asked for g of f of x, right? Okay, so I'm going to take wherever I see g is my outside function, f is my inside function. So wherever I see x here, I'm going to take my f function and plug it in wherever I see g. Okay, so I'm going to plug it in for this value of x here. So this is going to become 3 square root of x plus 2 minus 7, right? Because I took my whole function of f and plugged it in wherever I saw x in my outside function. Okay, well this question asks us to plug in 14 for x. Okay, g of f of 14. So wherever I see x, I'm going to plug in 14 minus 7. And again, let's see if we can solve this without a calculator, okay? Well, I already know from this question here that the square root of 14 plus 2 is the same as square root of 16 minus 7. Square root of 16 is 4, so 3 times 4 minus 7. 3 times 4 is 12 minus 7. 12 minus 7 should give me 5. Okay, so this is an example of some simplification you might have to do without a calculator. My final answer here is 5. Okay, the last question here says find g to the negative 1 of x. Remember that this notation here means inverse, which means to switch x and y. So g to the negative 1, anytime you see that notation with to the power of negative 1, it means find the inverse, so switch your x and y values. Okay, so I know that I'm working with my g function, which is this function here. So I've got g of x is equal to 3x minus 7. Okay, and I need to find the inverse because that's what this notation here means. Well, inverse means switch x and y. Okay, inverse means switch x and y, so it'd be helpful if I had an x and y in this equation. Reminder that g of x is the same thing as y. So we can rewrite this as y is equal to 3x minus 7. Next thing I need to do is switch my x and y values. So I like to leave a blank equals 3 blank minus 7, where I can then switch the place of my x and y values, but everything else about the equation stays the same. Then I'm going to solve for y or get y by itself. Solve for y or get y by itself. Okay? So if I am solving for a variable, I'm using reverse order of operations. First thing I check for is addition or subtraction. I see subtraction here, so I'm going to add 7 on both sides. That's going to give me x plus 7. These are not like terms, so they cannot combine. Equals 3y. Next thing I check for is division or multiplication. Well, I see times 3 here, so I know I can divide by 3 on both sides. So I end up with x plus 7 over 3 is equal to y. I've gotten y by, oops, almost cut it off there. I've gotten y by itself, so that is my inverse. G to the negative 1 of x is equal to x plus 7 over 3. Remember, inverse just means to switch your x and y values. These questions can be tricky because of the notation. Remember, if you see functions like this, it means composite function. Inside function replaces the x of the outside function. This notation with the negative 1 means inverse, switch your x and y values. Okay, that's it for this section. Let's look at one more question like this. Here we've got some graphs. Okay, this says write down the value of f to the negative 3. Okay, well the tricky thing here, what this is saying, we know that x is equal to negative 3, right? And this notation, this is f of x notation, so I know x is equal to negative 3. Okay? This is asking me when x is equal to negative 3, what is y equal to? So if I look at my graph, if I go over to where x is 3, sorry, where x is negative 3, I go the other way on the graph, excuse me. If I'm at x is negative 3, my y value at that point is right here, right? I go to negative 3, negative 1 to get to a point on my function. Okay, so when x is negative 3, my y value is negative 1. So my answer here is negative 1. Okay, so this question is really asking me, when x is equal to negative 3, what is the y value equal to? Well, on this graph, if I go over to negative 3 and go down 1, I find a point on this graph. So at negative 3, my y value is negative 1. Okay, next this says write down the value of f to the negative 1 of 1. So this is asking, remember this notation means inverse. Inverse means switch x and y. Okay, so what I'm going to say, okay, is what is the point on the actual function? On the actual function, when my x value is 1, what is the actual point? Okay, so I'm going to look up here on my function. When my x value is 1, so when x is equal to 1, my y value is equal to about 1.5, right? Y is equal to 1.5. If inverse means to switch x and y, okay, if inverse means to switch my x and y values, okay, then that is saying, when x is 1, y is 1.5, right? So if I want to find the value of the inverse function, I would have to flip these points, right? So on my actual function, I have the point 1, 1.5. That means on my inverse function, that point would be flipped. So my answer here is this y value, 1.5. Okay, because if it is the y value on my actual function, it'll be the x value on my inverse function. Okay, next we are going to look at domain. Domain means all possible x values. So on this function, I'm going to look at my lowest x value. Okay, if I took my pen, the first x value I hit is negative 4. The y value of that is what, negative 3? If I go all the way over, the last x value I hit is at 5, positive 3. Okay, so my domain would be just those x values on this actual function, but I actually misread the question, so this is asking me what the domain of my inverse function is. Okay, so if I was looking at the domain of my actual function, it would be -4 to positive 5. But what I need to find is the domain of my inverse function, right? The domain of my inverse function. Well, inverse again means switch x and y values. So the domain of my actual function will be the range of my inverse function. So the domain of my actual function will be the range of my inverse function. So the range of my actual function will be the domain of my inverse function. So my domain should be -3 because those are the y values of my actual function, to positive 3 because those are the y values of my actual function. Remember, for the inverse, we switch the x and y values. We're going to be able to see this on this last question. Let me grab one more color for this one. Okay, this one says, on the grid above, sketch the graph of f to the -1. So sketch the graph of the inverse. Okay. Inverse means my x and y values are flipped. So I'm going to write what our actual function, our x and y values are. We see we have -4, -3. Let's see if we can find some other points. Another one I listed was -3, -1, right? Another one we could list is 0, +1. Let's get maybe one more. 5, 3 is the other point we listed. Those are for my actual function. Yes, I'm running out of room here, sorry. Okay. Now for my inverse function, those points should all be flipped, right? So my x and y values switch. So let's plot that. So I'm now going to plot the point -3, -4. Then I'm going to plot the point -1, -3. The point 1, 0, so over 1, up 0. And then the point +3, +5. So that function ends up looking something like this, and that is my inverse function. All I did was pick points from my actual function, switch the x and y values to get points for my inverse function. Okay? Inverse is one of those concepts that if you fundamentally know that it means to switch the x and y values, you can figure out most of these questions. So write out the table of the actual function, switch the x and y values to find your inverse function. Okay, now we're going to go ahead and flip to the back. What we are doing here is starting our quadratics review. Oh, we're at the top here, sorry. Okay, we're starting our quadratics review here. We're actually going to start our quadratics review with an inverse functions question. Not an inverse function, excuse me, a composite function question. Isn't that fun? So on this one here, it says let f of x equal x squared plus 2x plus 1, g of x equal x minus 5. Our first question is to find f of 8. So that means wherever I see an x, I'm going to plug that in. I'm going to plug 8 in wherever I see an x in my f function. Okay, I'm going to write this down here. I'll do it on this side of the paper so we don't have things bleeding through. So I have the function x squared plus 2x plus 1. It says f of 8, so wherever I see x, I'm going to plug in an 8. So that'll give me 8 squared plus 2 times 8 plus 1. 8 squared is 64, plus 2 times 8 is 16, plus 1. And then I'm going to add all of those together. Paper. So 16 plus 64 plus 1 should give me 81. 64 plus 16 should give me 80, plus 1 should give me 81. So f of 8, oh, you can't see that, I'm sorry, let me zoom out a little. F of 8 is equal to 81. Okay? Next, it says find g of f of x. Well, let's color code my functions again. G is going to be my outside function. So g is x minus 5. f of x is going to be my inside function, x squared plus 2x plus 1. Okay, so g of f of x will look something like this. So anywhere that I see an x in this function, I'm going to plug in my entire f function. So I should get x squared plus 2x plus 1 minus 5. There's nothing that can combine inside of these parentheses. There are no like terms. So because of that, I can get rid of the parentheses, right? I've done all the combining I can within the parentheses. So this should just become x squared plus 2x plus 1 minus 5. These are my only two like terms, so I can simplify this all the way to x squared plus 2x minus 4. Okay, so when I've combined my functions, x squared plus 2x minus 4 for my composite functions. Okay, now here's where we get into a little bit of the quadratics. This says solve g of f of x is equal to 0. So this entire function, x squared plus 2x minus 4 is equal to 0. Now this should look like a quadratic because there are 3 terms with an highest exponent of 2, which means we have our a, our b, and our c value. I always check if we can factor these first. So I draw my quick little x factor. I've got negative 4 in the top and 2 in the bottom. I cannot think of any two numbers that multiply to give me negative 4 and add to give me positive 2. So this is something that can't be evenly factored. Okay, this is something that can't be evenly factored. So let's see if we can use a calculator trick to help us on this. Okay, remember when it's equal to 0, we are looking for x-intercepts, or where the function touches or crosses the x-axis. So on your calculator, and you can do this on Desmos as well, if you go to New Document, Add Graphs, we're going to type in our original quadratic equation. So I've got x squared plus 2x minus 4. I'm going to press enter there. Okay, and I have this quadratic function here. So I'm going to sketch that here. I've got this quadratic function. It looks something like this. My two x-intercepts are here and here, right? It's where it touches or crosses the x-axis. When I'm looking at this, it's really hard to tell exactly what those x values are. If you go to Menu, Analyze Graph, number 6 here, where it says 0, remember x-intercepts are also called zeros, we're going to hit Enter. This dotted black line, you're going to scroll once to the left of the first x-intercept and press the center button, once to the right of this x-intercept and press the center button. So that x-intercept is at the point negative 3.240. So that is negative 3.24 comma 0. That's one of my x-intercepts, but notice that I have 2 here. So I've got to figure out what my other one is as well. Same thing. Menu, Analyze Graph, we're finding the 0. We're going to scroll once to the left of the x-intercept and once to the right of the x-intercept. My other x-intercept, oh, whoops. It was at 1.24. Sorry, I entered away from it, but it was at 1.24, comma 0. So you can write your final answers as x is equal to negative 3.24 and x is equal to 1.24, or you can write your final answers as 2 coordinate points, like that. Both of these are correct answers because you've told me what your x values are. So biggest thing here is when we have a quadratic equal to 0, we can either try to factor to solve, or we can graph and look for the x-intercepts. Because when we see something like this, solve when it's equal to 0, it means find the x-intercepts. Okay, very last question on quadratics here. This is one of our standard vertex form. This one is a lot of notation as well. This one's a lot of notation as well. It gives us this graph here. oh, you can't quite see that. It gives us this graph here, right? This looks like our vertex because it is a minimum value. And this just looks like a coordinate point, right? This is just a coordinate point which is in the form xy. Okay? Big thing to remember with quadratics is when we write them in what's called vertex form, this h and this k value are based on the vertex. So h is equal to the x value of the vertex. K is equal to the y value of the vertex. Okay? So we should be able to read this graph and write down the value of h and k. Well, if this is my vertex, this is the x value of my vertex, that's the y value of my vertex. So this is h, this is k. H is equal to 4, k is equal to 2. Okay? Next thing, it says the function can be written in this form. We already know what h and k are. Find a. Okay, well, we have some other information as well. We know what h and k are, so let's plug in what we know first. I'm going to write the format of this. We have f of x is equal to a x minus h squared plus k. Okay, well, we know f of x is the same thing as y, so let's go ahead and rewrite it as y. Now let's plug in what we know. We know that h is equal to 4, because it's the x value of the vertex, and k is equal to 2, because it's the y value of the vertex. Okay, so I now have y is equal to a x minus 4 squared plus 2. Okay, well, this isn't quite enough to solve yet, because I still have too many variables in this. But the interesting thing is I have x and y, and I know a point on the graph that is x and y as well. So I can say x is equal to 0 and y is equal to 6 because I was given this coordinate point. So I can plug in whatever the x value of this coordinate point is in for x and whatever the y value of this coordinate point is in for y. So I'm going to do that next and now see if I have enough information to solve. So then that's going to give me, once I plugged in everything that I know, 6 is equal to a parentheses 0 minus 4 squared plus 2. Okay, now that we should be able to solve because the only thing that I don't know the value of now is a. So I'm going to solve that on my little blank sheet of paper here because I didn't quite give you enough room. Okay, so I've got 6 is equal to a parentheses 0 minus 4 squared plus 2. Okay, so let's do what we know in parentheses first. 0 minus 4 is going to give me negative 4 squared plus 2. Negative 4 squared really means negative 4 times negative 4. A negative times a negative is going to give me a positive. So this will be 6 is equal to 16a plus 2. Now that I've combined all my like terms on the same side of the equation, I can do my SADMAP, or reverse order of operations, to solve. Subtract 2 on both sides. 6 minus 2 is 4, equal to 16a. A isn't totally by itself yet. I'm going to divide by 16 on both sides. So my final answer would be a is equal to 4 out of 16. That can reduce down to 1 out of 4. If I divide both the top and bottom by 4, I should get a is equal to 1/4, and that would be my final answer here. A is equal to 1/4. Okay, I know that is quite a lot of information. That's going to happen as we get more and more into review. If you have any questions, please let me know. You should be able to do the you-try problems on the right-hand side of the paper. That's it. Bye-bye.